in the meanwhile, you can see in the screens what tu quello che vedi tu, what Matteo is seeing. Okay. In this presentation, we are going to show you 3 vehicles. Okay. Yeah. Yeah, I'm not starting. I'm just preparing.
Yeah, they are calibrating the headset.
Yeah.
So, as you can see, there is a QR code over there that is used in order to pose the vehicle in the right place.
Okay. If someone have the visor, can come here.
Pay attention to the vehicle.
Okay. No. Okay. You can wait here. Yeah.
C'è un veicolo, sì, quella è la visione corretta, c'è la moto, la macchina.
Sì, Modena.
Lui non lo vede.
Cambia il visore. Non l'hai avviato da 0?
Sì, sì.
Adesso arrivano pian pianino. Mettetevi magari non davanti agli schermi così gli altri vedono intanto. Matteo, mettiti da lì così... Ah no, sì è vero, non contro gli schermi, sennò si fa l'effetto. Ok? Okay, I just ask who don't have the visor. Okay, with the visor you can keep close, and the person without the visor I ask to stay far because you can't see the car, but there is a car actually. Okay, with the visor you can stay here in order to keep clear also around the car. Okay, for those already have the visor, this is the first car we are going to show you today. As I told before, today we are going to show you 3 vehicles. One is the vehicle of the University of Modena Reggio Emilia. The second vehicle is the motorbike of Bologna, and the third vehicle is the electric car of Parma. Okay, me and my colleague are going to show you and guide you through this AR experience. Okay, when we are ready, we can start. Ok, c'è qualcun altro che sta aspettando il visore? Ci siamo? Vabbè, nel frattempo partiamo? Ok? Can we start? Ok, again, hello everybody. We are going to start with the first vehicle. I know you already know this kind of car because some of you already designed a Formula FSAE car. You know exists electric car as yours, exists a combustion car, but this is the only one car which mount an hybrid power unit. Okay. Now we are going to show you some particular steps of the mounting of the hybrid power unit. In the meanwhile, if you want to try to sit in the car and try to see what the driver can see, if you want, don't be shy. Don't mind. You can't break the car. Okay, if you want, you can see here the dashboard of the car, the steering wheel. Okay, On the steering wheel there is a lot of...
I can't see anything anymore.
Anything? We can change the visor. Matteo? Lui non vede niente, se puoi cambiare. If you had some problem with the visor, my colleagues are going to help you and change the visor, okay?
Oh, it's here now.
Where do you see the car? Okay, there is a button with recalibrate. No, on the recalibrate.
Oh, yeah.
Touch recalibrate and see again the QR code. There is a check green.
The car's up now.
Okay, recalibrate again and try to stay still when you look at the QR code.
So you can go inside then.
You can go inside. You can try to see what the driver see. Okay, this is the steering wheel with the button of to activate the radio, the DRS system, and other function. The dashboard with all the switch for the electric system, the combustion system, because this is a hybrid car. And in the dashboard, in the display, we can also provide to the driver all the information about the car, about the state of charge of the battery, and the temperature of the engine, and all the systems.
So I assume that this can allow you to like uncover things, or
Yes, in a while, in the second step. What do you think about augmented reality? What do you think if you are able to use this technology during the design of your car? We already use this technology in the design phase in order to try to mount the component, as we are going to show you in the second step. I ask you to see in the back of the car, okay, when everybody can see the green arrow. Okay, let's now go to the third step. Okay, here you can see the hybrid power unit, okay, as we told before. Actually, this is just an internal combustion engine, okay. This is a Ducati motorbike engine. It's derived from a Ducati Panigale. Do you know Ducati Panigale? It's a very common and high-performance motorbike of the Ducati brand. Is a V-twin engine, twin-cylinder engine. Okay, this is the real internal combustion head that actually work on the engine, and this other head of the engine in different color is going to be removed in order to be replaced with electric motor. Okay, but let's now focus in the step-by-step process to remove this head. First of all, we need to remove all the screw and the bolt and the studs that fix the head with respect of the crankcase. Okay, I lost my dashboard. Just a moment. Ho perso la dashboard. Sto girando. Ho perso il dashboard. Eccolo, l'ho trovato. Sorry. Ok. Okay. The other step are the step to we have to remove the chain tensioner, the chain tensioner of the chain of the valve train transmission system. Okay, and then we can remove the head. Okay, as you can see, there is the chain of the valve train transmission system with his wheel. Okay. The chain, we are going to keep the chain in that position in order to use the same chain as a transmission device for the electric motor, as we are going to see in the next step. Okay. First of all, we are going to remove the old wheel. Then we are going to replace the studs, and then we can add a shorter one. Why? We are going to see in the next step why we need a shorter stud. This is the electric motor, okay? As you can see in the rear part of the electric motor, there is not enough space to use the original stud, so we replace with a shorter one. And this is a very particular electric motor. It's not a common electric motor. We don't both the electric motor on the shelves, but we produce for our needs. In particular, it is a custom electric motor PMSM that we realize for this application. The case of the electric motor is realized via additive manufacturing, okay? And in this particular application, we use the same system of the engine. In particular, we are going to use the same cooling circuit of the engine. The cooling circuit is connected in the deck of the engine, and the water flows outside of the stator of the electric motor. Okay. Then we can add again the wheel of the engine. Notice that we are taking the advantages of use the most of the original system of the engine in order to obtain a more or less a plug and go solution. Okay. Now we are going to put again all the screw of the electric motor, the bolt. You can see the bolt in this part, and also the other bolt in these sides. And then again, we add the chain tensioner. We design the shape of the case of the electric motor in order to use the same chain tensioner in the same position in order to be sure to use the chain in the same way. And then we are going to add a simple cover to cover the electric motor and the chain case. Okay? You have some question about this part?
You say you built the motor?
We build the motor. The case is realized in aluminum via additive manufacturing. Okay. Maybe we are going to show you in some other photo or video because the car actually exists and run normally. Okay. If you want to see some details, okay, inside the engine or something else. And then I'm going to come back to the car and show you some other features of this hybrid power unit. Okay? Come back again on the car. Okay, this is other features, other components of the car. This is the front suspension system. This is the rear suspension system with the hybrid power unit and all the transmission system. Okay, all the component of the suspension is in carbon fiber, the arms and the steering column, the steering wheel, and so on. And also all the monocoque is a carbon fiber, all the air package, and so on. Okay.
Can we have a closer look at the battery for the electric motor?
Not inside in this presentation, but we are going to show you some example of the electric vehicle battery. Okay. In particular, this yellow component is the fuel tank. Okay. The fuel tank obviously is connected through the internal combustion engine. This particular shape, I don't know if you already saw some combustion car, but this particular shape of the fuel tank is due to the packaging problem inside the cockpit, because we need to position both fuel tank and battery pack. Okay, so it's a very particular application. In green, you can see from this side the flow, the energy, the virtual energy flow of the fuel, okay, which is flowing through the engine. And this means that this is the first flow step of this power unit, which is alimenting the internal combustion engine. In green, you can see now the battery pack. The battery pack provides DC current to the motor converter. And then we are going to highlight the motor converter that, of course, convert the electric energy in AC current. Okay, that we can see the energy flow through the electric motor. Okay, I lost again my dashboard, so please be patient. Okay, okay. And then after we convert the electric motor, we can provide, okay, this energy, this electric energy converted in mechanical energy through the transmission system. So in this phase, both electric motor and internal combustion engine are providing kinetic, mechanical, and energy through the transmission and then through the wheel, and then of course to the vehicle. Yeah, in this phase, yes. Sorry?
The disconnect plug is underneath the driver directly. Is it easy to access?
Here is the plug of the battery.
Yeah, the disconnect.
I don't know
At the
if...
side of the battery, it looks like a
Yeah.
connector. Is that
Yeah.
like a safety disconnect?
Yeah, it's, maybe we are not perfectly aligned.
Ah, okay.
You mean the black one?
Yes, yes, yes.
Maybe here, but here?
Yeah.
Yes, is the plug of the
It's
battery.
easy to access for the driver?
Not for the... No, because here there is the firewall, so the driver is not able to access to the plug. We need to remove the firewall.
So you have to...
Yeah, maybe we can go at the... Okay, here you can see the seat and the firewall, so there is no way for the driver to plug. We can...
We don't want the driver to access the
Okay, the next step. Now we are going to analyze the reverse flow, okay, when the car is braking, okay? The kinetic energy of the vehicle is converted in mechanical energy by the transmission and then provided to the to the powertrain, to both electric motor and internal combustion engine. These two motors are always connected, so it's a hybrid architecture in P1, okay? In this phase, the internal combustion engine is switched off, okay? You can't see any flow from the fuel tank to the engine, but the electric motor is able to convert this mechanical energy in electrical energy and then convert it and store in the battery pack again, okay? If you have other questions?
Other than the energy coming from the motor, does it have regenerative braking?
Yes, only from the rear axle, of course. Okay.
I have a question. So this is, so if you go on AR and you
Yep.
have an engine already ready,
Yep.
can you mix both the reality and augmented reality? So you'll have a physical motor with some pieces you want to go inside?
Maybe yes, but not actually. Maybe we need to talk with the programmer and then maybe they can make something
So in
similar.
other words, we'll have a car,
Yeah.
and then we want to go inside the motor, and then we put the VR and we go inside, and we go and explore it.
Yeah, maybe yeah. Yeah.
The only thing you will have is actually avoiding the physical car, right?
Yeah, yes.
Trying to avoid to make sure that
Yeah, actually this program what we are looking now is more easy in order to be a kind of reliable program. Okay. Okay, now we are going to, yeah?
control the strength of a braking with the electric.
Yeah, this is a good point. This is a good point. We have not so much time, so I suggest to go ahead to the other, and maybe I can reply you in a second moment. We are up currently studying this kind of pedal feeling of the driver and this subject because it's a very good point. Okay, we currently use electronic brake repartitor. Okay, the normal in front and rear, and another brake repartitor between the electric motor and the mechanical system. Okay, and which is electrical actuated because it needs to know the state of charge of the battery, the temperature, and with respect to this, we need to decide. Okay, so we can go ahead with the second vehicle. In particular, here you can see the electric motorbike. I can switch the visor with the team leader of the project that he is going to show you the motorbike.
Okay. Good morning, everyone. Do you see the motorbike? Okay. I'm Andrea from the University of Bologna, and I'm here to show you our last prototype of electric motorbike. Okay, let's start from the most structural component, the frame, the chassis. This is a carbon fiber monocoque frame with a structural core and some aluminum inserts. And the shape of this frame is very particular. This is due to the fact that the frame itself has been designed around the electric powertrain propulsion system. And so here it will be inserted the battery pack, and behind there will be the electric motor. Now we see the assembly procedure. It's fully electric, yes. Yes, this is for the motor steering competition. Okay. Okay, this is the dashboard support. Here the rider can interface with the basic functionalities of the motorbike. Now let's focus on the rear side with the assembling. Excuse me. With the assembling of the footrest. Fun fact, here you can see that that a lever is missing. This is due to the fact that our motor has not a gearbox, so it is a one-gear electric motor. So here you can see the assembly of the rear part. So the swing arm made in CNC technology and the monoshock absorber. And then we can complete the rear side, the rear part, with, Okay, these are the connections from the swing arm to the frame. And now we can complete the rear part with the rear train, the wheel, and the rear sprocket. Okay. Now I ask you to focus on the front side. If you can follow me. Vediamo se questo mi segue pure. Okay. For the front train, we start from the wheel already connected to the forks. Then the subsystem is mounted on the steering plates, the aluminum steering plates. And after the assembling of the semi-handlebars, the whole system is bolted and assembled. Okay, now we can focus to the most interesting part of this motorbike, the electric propulsion. As you can see, the motor has been assembled, and we can complete the propulsion. Follow me, please. The propulsion with the chain. Okay. And now the 42 kilowatt of power are arrived to the rear train. Okay. Now you can see the battery pack. I repeat this movement again. Okay. Cells are inserted, welded, and connected in series and parallel inside the battery case, and then the electric the electric parts like the IMD, the insulating monitoring device, and the BMS, the battery management system, are added. And finally, this is the motor controller. Okay. And now the whole battery pack is inserted into the frame, and we can pass to the aerodynamic parts of this motorbike. Okay, you can see the assembling of the mudguards, the tail fairing, and the tank fairing, sorry. And now the front fairing and the lower one. Okay, do you have some questions about it?
What are the specs of the battery?
What?
What are the specifications of your battery?
Oh, okay. It has a maximum voltage of 130, and well, it is DC current, and it has capacity of around 6 ampere per hour.
Oh.
Okay. It has been designed for the Aragon race, so it can make around 30-35 kilometers, which is the 6 laps of the Aragon race. Okay. Now let's pass to the power flow part. This is the motorbike again. Here we can see all the motorbike in transparency, but the powertrain components. I repeat for you, this is the battery pack, this is the motor controller, here is the motor, liquid cooled, and the rear train complete. Okay, so the flow, the energy flow starts from this quick connector up on the battery pack, and the cells inside the battery pack store the electrochemical energy. Then this energy is supplied to the motor controller, and finally arrives in as electric energy to the motor. So the motor transforms. Do you have some question?
No.
Okay. So the motor transforms the electric energy into mechanical one with the rotation of the rotor of the shaft of the pinion, and finally the rear train can accelerate, can consent to the motorbike to accelerate and to race. Okay. The motorbike, the electric motors, as you know, have the feature to use the regenerative braking to store some energy into the cells. So starting from the mechanical energy, we pass to the electrical one, and finally the electrochemical one into the cells. Do you have some questions about it? Okay. Okay. I think we can pass to the electric vehicle. Yes, ma'am. No, sir.
Okay. So now I will talk about the car of the Emilia racing team. You can see it in front of you.
The electric one?
Yes. I will talk about the powertrain, the electric powertrain,
Yes.
in particular on the battery. So, starting with the presentation, here you can see the core of the battery. It's one module. It has a tension of 100 volts. Here you can see the battery management system. It's a PCB. Then you can see the copper bus bar that connects the cells.
The battery management is team built.
What?
The battery management is team built.
Yes, it's a PCB board, and is provided by ourselves.
Yourself. Oh,
Yeah.
wow.
It's made by ourselves.
A lot of work.
Yes. And then here you can see the cylindrical cells are lithium battery. There are 24 series and 4 parallels. Then the blue square is a graphite and paraffin material. Is called PCC material because it changes phases. And while changing phases, it absorbs the heat spread by the cells during the competition, and keeps the temperature constant because it's changing phase. So like the ice in the water, while it is melting, it stays at 0 degree.
What is it called again?
PCC. Is graphite and paraffin, and the graphite spreads the heat and the paraffin absorbs it. And then you can see the chassis of the module is made by aluminum and keeps all together, the pieces. Now we will assemble it like this. Here are the plus and the minus terminals.
So the metal bars separate the battery management system?
The metal bars, this keeps the cells and the graphite on the back of the chassis, because from the rules we need to withstand the 40 G of deceleration, so we made the chassis in aluminum. Then we can assemble the module that we saw before in the wall battery. There are 6 modules that together forms the battery, and then they have 600 volts and 6.2 kilowatt hours of energy stored. 6.2. Yes. They are connected with the cables. Also for the rules, you can build all in one battery. So then you can see on the upper part the case that need to withstand a 40 G acceleration impact, and the upper one that stores the electrical management of the battery for the safety of the battery. It manages the temperature and the voltage of the series of the cells. Now we can assemble it, the whole.
That's team built?
This is carbon fiber.
The management, is this one team built?
Yeah.
Also.
Yes, there's inside of the upper case there is the BMS master.
Yeah.
And all in the modules there is the slave that is connected. Is a type slave master. What?
How do you cool? Are there fans somewhere?
No, it's only with the PCC material.
Okay.
It absorbs the heat, and then after the race, we leave the battery alone for 1 or 2 days, and then it spreads the heat slowly. No. Okay.
What will happen if I had a virtual hammer on that? If I hit with a virtual hammer the case?
It doesn't break because there is also a test for the perforation. So also with the hammer and a lot of force, you can't break it. So
It's able to withstand
yes, 40 energy.
absorbed
Yeah.
by FSAE.
And also the acceleration of 40 G and the penetration. So going forward, we can see the rest of the powertrain without the motors. Here you can see 2 inverters and a power box junction. in this box we split the power from the battery to the two inverters. You can see here the cables that goes to the inverter. The inverters convert the DC power to AC. Then we will assemble it. We put everything on a shell so it can stay in the car while we put away the battery to charge it. Then we can add the motors. They are MRAX 188. They give 8 kilowatt power each with 90 newton meters of torque. And in series of that, we have a planetary gear that reduces the rotational velocity of the motor by 3 times. And then at the wheels, we have 600 newton meters of torque each. So we choose the 2 motors to split the torque and have better control on the car. Now we had the chassis and the cables. And after that, you can see the aerodynamic devices mounting and then the suspension system. Now I will show you the power flow of the car inside the powertrain. Here you can see the whole powertrain mounted. As I was telling you, the power from the battery goes to this junction box and it's divided in 2 to the inverters and then to the 2 motors. Here you can see, as in the car and also on the motorbike, the DC power enters into the inverters and goes to the motor in AC power.
So you have your relays in here?
The relays, no, they are in the upper case of the battery with the BMS. Okay. The next slide is the regenerative braking, when the inverters allows the current to flow back to the battery. And if you were asking what we have in the junction box, we have also the SPD and the EMD latch. My presentation is finished, so I pass the master.
So, to see if everything was fine also for me. And we will change the subject a bit in the last 5 minutes. I'll be brief, I promise you. And we will talk about testing, in particular Nvh testing. I won't bother you with too many details. I just decided to show you a video. It should pop up somewhere above the vehicle. Okay, so okay, probably I should calibrate because everything is just all over the place. But yes. Everyone can still see the car? Okay, perfect. We can start with this car, which is electric, and we brought this car in this special room. It's called anechoic room. In order to let you understand what it is an anechoic room, without many explanations, just have a look at this video. So this is the anechoic room, quite impressive, isn't it? It's not just a nice room for video shooting or photo shooting, but this is actually a laboratory. A laboratory in where we can study sounds. Sounds are waves, basically. They propagate and they interact with everything they encounter on their path. In this way, they are not bouncing back into the room. So we can study everything from the acoustic point of view. So we have any kind of sources. In this case, they were 3 vehicles, studied one by one, and so we put a lot of microphones all around it, and we use special instruments, which are called beamforming antenna, which allows to visualize sound, something that usually we perceive with other senses. We can actually put on an object or on a surface or a virtual surface and understand where the sounds come from. And what you see on this vehicle is a color shading map, and red tones means high noise, blue tones or white is no color basically, means low noise or sound, if you really like what you will hear in a while. Basically, you have the sound coming all from the back of the car, and you can also see something coming from just the back of the driver. This is a fan, so high-pitched noise, you understand the concept of frequencies. It's just a number of times each particles oscillate in a second, but from the perception point of view, you can understand frequency by the pitch of what you're hearing. High-pitched sound is high frequency, a low-pitched sound is a low frequency. And we can study all of this stuff in this anechoic room, and we can do that for cars, for racing cars, for normal cars, but for any kind of source also, like any machine used for industry or any appliance you can think you might want to install in your apartment, everything. And we can do that for certification purposes. So a company just asks, we need a noise certification. Can you do that? Of course we can. Or we can do optimization process. So we study the object, how it emits sound, it's generating sound, and we change the sound it generates. We also may study the sound of the button inside of a car, because they need to sound in the right way, otherwise people won't buy it. And we can also use this room for research purposes, of course. We will hear the sound of this car, which is very peculiar because this car is electric, so the sound will be very high-pitched, and then we will try to compare it with the other cars. Just a quick reminder, you have a volume button on the right side of your headset. Just lower it down if it's too loud and feels uncomfortable. So this is the high-pitched noise recorded with low resonance of scale. It's not a very interesting condition, but it's a condition that allows us to compare different things. Give me a second to go back maybe to this car, which has also a combustion engine, and we will of course skip all the starting video, and we will go just to the last car. And the motorcycle is electric, so you might think the sound will be similar to the one of the electric car. Well, let's hear it. activity we might perform in the acoustic vibration group as two different research groups, but we very often work together in order to characterize how the dynamic and the sound interact and in how we can make it better. Thank you.
Okay, so thank you. Now we have the last 1 minute if you want. Just to show you that the virtual vehicle is a real vehicle at the end. So I kindly ask you, Professor Gattini, to join me here on the floor. And then just a few more information about getting quite cool. 5 minutes and 5 minutes for presentation number 3.
Morning, everybody. My name is together with my colleague Davide Zenka. We are two of the founding advisors of the Learning by Doing project at the MUNER. In the next really few minutes, okay, we are going to add some technical details about the different prototype vehicles. Okay, you've seen in the augmented reality experience, just to add very few information. Here, nice picture of the car. You've seen a sort of rendering. Okay, now the car is here. We're in Italy now. Here, a list of the main performance characteristics of the car. It has about a peak power of 80 kilowatts. Maximum velocity of maximum speed of 150 kilometers per hour, and a 100 acceleration time less than 3 seconds. Okay. It's equipped with a carbon fiber chassis, an advanced suspension system, a full aerodynamic package, and obviously a high power unit. So I'm going to speak details about why units is a good experience, okay, in augmented reality. Just a few words about the manufacturing process, okay, of the case, of the motor case. Since it's quite complex as a geometry, okay, it includes the cooling system and the unique component, and so this is the reason why it has been produced, okay, adopting additive manufacturing and manufacturing technology. Just an additional detail about the power unit, okay. It is a bit, it's longitudinally installed into the car, okay, and it's a unique characteristic of this car, okay, and